Hello everyone, hello everyone, hello Zimbabwe, hello Africa, hello the entire world. Welcome to my channel BST African Electronic Surgery. And yeah, we have to fix something. It's around 8 p.m. in the evening, and we have this job. This is coming from another city, the second city of Zimbabwe, that is Blawayo. So the job is coming from another tech. He phoned me, explained me the issue about the laptop. So we have to try to fix this. But you remember the last video? Yeah, that was too controversial. But I was just trying to explain my feelings, about those kind of people who don't want to change. There are some kind of people who are resistant to changes in technology. Even if more devices come, you still want to use that old device. But anyway, I hear all the opinion and I really accept that at some point we have to help them. We have to help them. But that it affects me, if I'm fixing that kind of machines and someone is fixing like the updated machines in line with technology. So let's see. This is HP 250 G7. It's an Core i3 processor. And what the owner is saying, HP 250 G7 product ID, dead motherboard, no battery, no hard drive, no charger. Okay, so we have to put the diagnosis and try to fix this. Either we'll manage to fix or not, but it's good for the technician to know how we can diagnose a dead laptop motherboard. Okay, so the first step, let's jump into business. This first step, let's check the charger voltage. You can see on the screen 19.52. The charger is good. Plug in the charger. On the HP, you must have some light here, but we don't have light. The laptop is dead. So let's see why this laptop is dead. Let's see why this laptop is dead. Where's my screwdriver? I can't see my screwdriver, so we have to use this manual. I can't see my electric screwdriver. So that's the thing. Let's see if we can help our subscriber with this dead device. Yeah, the laptop came like this with a few screws. I didn't open, I didn't check anything. So that's the laptop. That is our laptop. So what we can check, we have the fan, DDR4, 4 gig RAM, DDR4. This is the placement to have the battery. The battery is missing. HDD drive is missing. Okay, like what the owner is saying. We do have the charging port here, which is coming here. And we have those MOSFET in serial mode, current sensor, and some coils. This is some kind of new model. And Yeah, we don't have too many components. We only have too many chips there because the MOSFETs, in most cases, they are inside the drive. They are inside the driver. But we'll see. We'll see. So let's see what's going on here. Let's plug in the charger. Obviously, we don't have a light on the charging port. Why? Because the technicians phoned me and said that the 19 volts is okay, but the 3.3 is missing. Yeah, that's what he's told me. But we'll see that. So on the plus of the charging port, 19 on the input of the first MOSFET, which I believe this is the channel N MOSFET. We have 4 pins together, which is a drain, and the 3 pins together, which is source. The output, we have 19. The on the current sensor, we do have 19 volts. So our 19 volts is present. So the technician was correct. Even if I'm to check on any power supplies here, we must have 19. Yeah, we do have 19.53. Even here, 19.53. So our 19 volts power rail is present. The next step is to try to check for 3.3. We do have this BIOS chip. On the last pin of the BIOS chip, that the VCC pin, we must have 3.3 volts there. And we don't have any voltage. On the coils, here, we have 0 volts, 0 volts, 0, 0, 3.3, and here 0.6 volts. Okay, this coil is 3.3. Okay, all right, I get it. You know what? This 3.3 was about to confuse me that the 3.3 volts power supply is on. The 3.3 volts power supply is not present. Why am I saying so? Because we do have the coil here. Let me unplug the charger to just to prove this 3.3 has nothing to do with the 3.3 volts, which is always on. Diode on this coil, we have 3.3, and next to this coil, next to the coil, this coil we have 3.3, and next to the coil, that's the BQ chip, BQ735 charging IC. So if I'm to check this coil, the relationship with this coil to the BQ chip, check. Can you hear the beep? The problem, my probes, they are too big to touch the pins of the driver. I understand why, but straight I have this capacitor which is going straight to the BQ chip. So this 3.3 is for the power supply, which is meant to charge the battery. And when you plug in the battery, the voltage will rise and will supply current to charge the battery. Remember, we explained that batteries are charged on current basis. This 3.3 has nothing to do with charging the battery, but this is the power supply to charge the battery, and we have 3.3 there. Let's check out the motherboard. Let 1 second. Let's check few things. So I put our multimeter on diode, the beeping mode. What I want to check, the resistance of each coil to ground. It's not beeping to ground. This is good. 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 How about this one? All the coils looks good. What about on the last pin of the BIOS chip to ground? Pin number 4 is ground, and pin number 8 is not ground. Okay. .6 kilo ohms here, 276 ohms here, 68 ohms here, 68 ohms, which I believe this is the vehicle section for the processor. Okay. And here, check on this coil. But I checked it before, it wasn't shorted to ground. Why? Check. It's like 0 ohms. So something is not right on this coil. The last coil is beeping to ground, like 0 ohms. Okay. So I think something is not right there. So why this coil is beeping to ground? One more time. Yeah. It's like 0, 0. So we have a problem here. The thing, I don't think this BIOS chip has anything to do with the EC chip. Let's check out the motherboard. Let's check out the motherboard. Let's check out the motherboard, because we have to do this job the right way. We have to do it the right way. Otherwise, we don't need the fan yet. Okay, so what is on the other side? 1 second. 1 second. So let's play with this motherboard. Okay, so that the other side of the motherboard, we do have the E.N.E chip, this one. Okay, so it's now time to find the 3.3 volts power supply. But so far what we discover something is not right to on this power supply, which we don't know what is the power supply it is, because the resistance of this power supply is like 0 ohms, like very low resistance. This is our first suspect, which you don't know. So let's concentrate on the EC chip. On the EC chip, what we are checking? We are checking those ceramic capacitors around the EC chip. Or what we can do, let's check from the last pin of the BIOS chip to see if this BIOS chip is for the PCH or is for the EC chip. Okay? So I'll stick one probe on the last pin of the BIOS and we'll try to see if there's any link with this chip. No? So this BIOS chip has nothing to do with this EC chip. Fine. So these are some kind of EC chip with the BIOS inside. So what I will do, I will concentrate on those capacitors. The first capacitor, all sides they are beeping to ground. That looks weird again. This side, here. We do a few more capacitors. Second capacitor is beeping both sides. Okay. We do have some more here. Third capacitor. So we have like 3 capacitors beeping to ground. Like both sides beeping to ground. Okay. You know what? Now it looks weird because if those capacitors are like 3, they are beeping to ground, probably those are the power line for the 3.3 LDO, which is always on. So the next step, let's try to separate these power supplies and concentrate on the 3.3 if we are lucky to find the 3.3 volts. So here we have this coil, probably is going to the USB. No? What about to the RAM? Zero zero. So this coil, this one, for sure, this is the RAM power supply. So if not, let's eliminate that coil. Okay. This one, which has got BQ, that's the charging coil. That's the coil for the charging circuit. This one, obvious, can be the 3.3 because it's close to the processor. Probably that's for the GPU. This one and these two, I can see big power lines which are going straight to the processor. This is the vehicle section here. So we are only left with the two coils. We are only left with this coil and this coil. So on this coil, one must be 5 volts, and this one, the other one must be 3.3. I don't know, but we'll confirm that. We'll confirm that. Check on the USB ports. The USB ports, the plus is also beeping to ground, straight on the 5 volts power rail. So that's clear. This must be the 5 volts power rail. And we are left with this coil, which is, if we check on the other side, we have the ENE chip, and here we have a coil. So this is the three. This must be the 3.3 volts power supply. You know what? We need assurance here. We don't want guesswork. So let's try to look for the schematics. I'll come back in a second. Okay, I'm back. I just took something like 10 minutes to look for the schematics, and I found one from the Disco server. You know, I'm on the global chat room from Electronic Repair School, Disco server. Someone sent me the schematics. So let's go on desktop, and where is our schematics? Where is our schematics? Here. So that is schematic for this board. It's HP250 G7. We have many things here. We do have many things, but let's look for the power supplies. What is this one? SKL. Where are the power supplies? Where are the power supplies? HDMI connector pinout. No, we don't need HDMI. We need power supplies. You know, the driver for the network driver, we don't need it. Where are the power supplies? That's the ENE. You see ENE? That's our ENE chip. So on the ENE, what we are going to check on the ENE, we are going to check. We checked on the capacitor around the ENE chip. You can see this 4.7 microfarads capacitor on pin number 124. I think it's one of the capacitor which we checked, and the capacitor, we found like 3 capacitor beeping to ground. Okay, where are my power supplies? SATA. battery connector, plus and minus, and then clock and data pins. It's easy to fix things with the schematics, but it's long. That's why I tried by all means to avoid schematics. I don't want long things. Now we do have the DC in, 19 volts. You can see 19 volts V in here is coming to this MOSFET, 4 pins together, 3 pins together, which is drain, and the gate is going straight to the BQ chip, BQ, to 2735. 2 MOSFET in serial mode, and you have the current sensor. And here we have like this MOSFET G1, G2. This is like a double MOSFET and coil to charge the battery. This is the power supply which we checked, and we have 3.3. This power supply, this one, and the power from the battery is coming from through this MOSFET source to drain and to the motherboard. That's the charging circuit. Now we have those coils, the 19 volts, 3.3 OS. Which chip is this? Because we want to try to look on the schematics, and then we replicate what we've seen here. 3.3 OS, that's the SY8286 BRAC driver. This is like a different configuration. On many cases you find something like this. In many cases you will find something like this. You will find something like this, you see? Like driver, this is TPS 5113. Let's continue checking few things. So, like what we are saying what they did here. The 3.3, I explained about these things. This power supply is like power supply which is supplying 4 outputs. We have 3.3 OS. You can see this 3.3 OS here, and we have another 3.3 volts here, and on the 5 volts, same 5 volts OS, and another 5 volts power rail. So it's supplying like 4 outputs. So that's the thing. So let's try to go back to our problem. So we've seen schematics, and so let's go on a microscope and see what's going on here. 1 second. So let's see what's going on a microscope. Let's see what's going on here. This is our motherboard. We have the charging port here, and after the charging port, we have those MOSFETs, like they are clear. We can clearly see the path. Two MOSFETs. So our 19 volts, we see this big power rail from the red wires, which is the plus, is coming through this resistor or inductor. Looks like an inductor, a big power rail which is coming here on the BQ PQB11. That is the first MOSFET, four pins together, and is passing through this to the output. And we have another MOSFET, small one, which is coming to this resistor. This other MOSFET is for, we have a coil here, is for the next power supply here. Okay. So our problem is on the other side. We're just replicating what we've just explained. Nothing special here. So that's our EC chip. Putting multimeter on diode mode. Let's check those points which we checked before. I checked here. Next to the EN, we have this chip, because on the other side we have that coil, which I believe is the 3.3 volts power supply according to the schematics. This one, PL303. So we have some capacitors. Let's check this capacitor. I'll stick one probe on the ground. Check this side, ground is beeping. The other side is beeping. That's not normal. And here we have another capacitor here. I need a proper ground. I need a proper ground. Can you see the beep? One. Check this capacitor. This one. You see that ceramic capacitor, which is beeping. This is the driver, which I said is the SY 82, 86, if I do remember well. You know, everything these days, they are trying to make things complicated. You no longer have a chip number on the chip. We have like codes. You have to look for the schematics or to go on Google to find the real number of that chip. So this is our driver, and this capacitor is beeping, which I believe is on the output. The bigger one is not beeping. You can see this big power rail which is coming to the chip. I believe this is the V in, and the output is shorted for the 3.3. Fine. On the chip, where I checked again, I checked here on this small guy, short. On the other side is shorted. So we need to plug in the charger. I'll plug the charger and we try to check some voltages straight on the On the chip, what kind of voltage do we have there? Volts. The charger is plugged. I'm checking here on the V in of this chip, which is the 3.3 volts power supply. We have 19 on the output. Obvious, we have 0 because the output is shorted. And on the chip, I'm checking on each and every pin. .75, that's the highest voltage. So why the chip has no output? Because that 3.3 is meant to be on all the time. So why this chip has no output? Either the chip is dead, which is another problem, and on the ENE chip we have like two capacitors shorted to ground. So let's come with the power supply. You know how we are finding short, coming with some amps and see what is taking power. Let's lower the voltage to 3 volts. 3 volts is good because this is the even 2 volts. 2 volts is fine, just to be on the safe side. I'll see here where we have a short. How many current? We have 3 amps. Here is taking 3 amps and 1 volts, and on the other side it's taking nothing. Okay. What about on those small capacitors? 3 on the other side. It's taking like 1 amp. The controller is not taking power. What is taking that voltage? Two volts. Something must be taking that current. Something must be very, very hot with the 3 amps. No? 3 volts. I can't see what is getting hot. So I'll go to 3 volts and we'll raise the current 3.7 volts. But something is taking that current. Something is taking that current. You know what? We have to take out the heatsink here. Probably the processor is misbehaving. I'm taking out the heatsink on the processor because I need to see where my heat is going. We have to see what is taking that current. We have to see what is taking 3 amps. Probably it's just a waste of time. A waste of time repair. You know what I mean? So again on the EC chip, I'm trying to get rid of the processor. That's what I'm trying. Yeah, now we have a problem. We have a problem because what is getting, it's not like what, but it's taking that 300 milliamps is the processor, and that 3.3 is for the PCH inside the processor. It's for the PCH inside the processor. So the 3.3, you see the number of volts that we have here. The chip is gone, and two capacitors. This one, this one, and another one here, which I believe they are connected on the 3.3 always from that driver, the SYE8286 driver is shorted. Is shorted. You see this capacitor? 0. So coming with the power, the processor is taking around 800 milliamps, and that is a problem. That is a very big problem which we can't solve. 3.3 volts. And here, just to confirm that the processor is gone, let's check out this chip and see if we will still have a short on those capacitors. So let's check out this chip. It's dead already, so it's not a big deal. Let's check out this chip. Let's check out this chip. Well, the chip is faulty. This chip is faulty. Our chip is out. Now, we need to check that capacitor again just to confirm if I was right or not. Because what I'm seeing, check on the capacitor, it's not shorted anymore. So for sure that driver is gone. Remember this capacitor which we checked before and is not short anymore. Let's go on those capacitor on the EC chip. That's crazy. On the EC chip is still shorted. Check here. Check this capacitor, short. And this one, no, this one is not shorted anymore. But this one is shorted. So let's come with power on that capacitor which is still shorted and see what is the problem. .7. The processor is taking 3.7 amps and is getting very hot. Very hot. So I'm sorry. I'm sorry, my friend, wherever you are. I tried, I can see on my OBS 49 minutes trying to figure it out what is the problem, because it's not allowed as a technician when a device come in for repair and you say to the customer, I don't know what is the fault. It sounds unprofessional. So the first problem that was found, the driver is shorted and we still have some capacitor around the EC chip, and if we inject 3.3, the PCH is getting hot, meaning to say the PCH is inside the processor and our PCH is gone. That's what it means. And On the 5 volts power line, maybe we can confirm to see, was I checked? Maybe that was voltage before. Yeah. No, the 5 volts. Let me check on that coil. Remember that coil. This coil to ground. Yeah, so that was voltage. So we have like 2 volts here. We have 2 volts. And even if I was going to look for this chip, and replace it, still we have the problem with the processor. So that's the thing. Since it's coming from another technician, let me just put it back, but the chip is faulty. The chip is faulty. Our chip is now in place. A faulty driver. So the driver which is fault is this one. Is this one. This one, that's the SY8286B. Because this capacitor on the output, this one, 4.7 micro capacitor, is shorted to ground, and we took out the chip, and the chip is shorted. So that's the thing. So yeah, that's unfortunate. We can't fix this one, but you hope you see how we try to diagnose the fault. Yeah, that's unlucky case. So like, subscribe, don't forget to turn on the notification bell, and see you on the next one. Bye. And see you on the next one. Hopefully sometime in the future we'll be in a position to help the customers from outside town, but there's nothing we can do. Mostly if you have a dirty CPU, you can't do anything. In our case, it's the PCH, which is inside the the, the CPU, because it's being supplied with 3.3 volts, and all the outputs for the 3.3 LDO and the main 3.3 volts, all the outputs, they are shorted to ground. The one is this chip. This chip, that's our first fault in the processor. So I can't fix this one. I'm very sorry. So see you on the next one. Bye.